go on and get started with this here. Our 2.2 notes. So again, we're still continuing on parabolas, our quadratic equations. And we're going to be looking at key points or key parts of the parabola. Now, the first equation we're going to look at is vertex form. The f of x equals a times x minus h squared plus k. And the reason we call it vertex form is, well, the h comma k is the vertex. So the h and k values in this form give us the vertex. Incidentally, we can also get the axis of symmetry, the equation of a line that will cut the parabola in half. For this here, x is equal to h. And that line will always go through the vertex. And we can use this information to be able to graph it if we're going to graph the equation of the parabola. And with a parabola, we need 5 points to be able to graph it. We need the vertex, 2 points to the left, and 2 points to the right to be able to get a good graph of the parabola. So let's go on and look at this first example here. So I'm going to relate it back to the general form, our a times x minus h squared plus k. So we need to find the values of a, h, and k. Now for this problem here, the value of a would be -2. H would be -3. Because since we have x plus 3, the only way we can go from x minus h to x plus 3 is if the value of h is negative. And our value of k is positive or -4? Positive. Now our vertex is the point h comma k, because when it's given in vertex form, we just need to plug in h and k in their respective spots, and we will have the vertex. Now the value of h for this here is -3. The value of k is +4. So we have our vertex. Now we can simplify axis of symmetry as a of s. But the equation that represents the axis of symmetry is x is equal to h. So we'll replace h with its value, which is -3. So that'll give us the vertex and the axis of symmetry. Question. Of S? Axis of symmetry? A of S? So axis of symmetry, A of S. It's just short, abbreviated for axis of symmetry, so that way we don't have to write out axis of symmetry every single time. Now, we're going to actually graph this one by hand. And if we go about graphing it by hand, the first thing we need to do is plot the vertex. So that would be the point -3, 4. So we have this here. Now the axis of symmetry is going to be this vertical line going up and down through that there. Now, the nice thing with using Smart Notebook or programs like it is I can draw this dotted line very easily. Now, for a parabola, we need 5 points. And one of those 5 points is the vertex. From there, we're going to take 2 points to the right and 2 points to the left. So I just start with -3. We go over 2 to the right, so -2, -1. We also go over 2 to the left, -5 and -4. Now at this point here, I'm just going to plug these x values into the equation to find its corresponding value of y. So we can start with -2. So we take the equation -2, replace x with -2, plus 3 squared plus 4. So we're plugging -2 into the function to find what it equals. Now at this point here, we can just plug this all in to the calculator. So we can say -2 parentheses -2 plus 3 squared plus 4 is 2. So our next point that we found is -2, 2. Now we're going to do the same thing with -1. Plug it into the equation and say -2 parentheses -1 plus 3 squared plus 4. And it is -4. Not the right point. So -1, -4 would be our next point on this parabola. So far we've got 3 points. We need the last 2. We need to find the y values for -4 and -5. Now -4, we can say -2 times -4 plus 3 squared plus 4. So we can write that out and plug it in. -2 parentheses -4 plus 3 squared plus 4 is +2. Now that should be kind of interesting, because when we went 1 point or moved 1 spot to the left, we got a y value of -2. We moved 1 unit left, or sorry, 1 unit right, got a y value of 2, yes? We moved 1 unit to the left and got a y value of 2, yes? Okay. So I moved 1 unit and got 2. Moved 1 unit and got 2. Well, the next thing we did is we went 2 units over to the right and got -4. What do we expect to happen if we go that same distance of 2 units over to the left? We should get a y value of -4, yes? Well, let's see. -2 parentheses -5 plus 3 squared plus 4 is indeed -4. And the reason this works is because of the fact that we do have that axis of symmetry with parabolas. Because that axis of symmetry cuts the parabola in half, and points are going to be equidistant from each other. So since we went 1 unit to the left, that point is also going to be in the similar spot to 1 unit on the right. They will have the same y value. So this is kind of nice because now I really don't have to calculate all 4 points. Once we find the vertex, those 4 other points, I only need to find 2 of them. Because if I find the 2 points to the right, I know what the y values for the 2 points to the left are. I don't have to find all 4. Questions on this here? Or what we can do is we can take the graphing calculator. Let's say -2, parentheses, x plus 3, close parentheses, squared plus 4. And that's pretty much what we got. The graphing calculator will do these for us, but we do need to be able to know and interpret the different parts of the equation. A, H, and K. So looking at this here, what's the value of A? 0.5. What's the value of H? -4. And the value of K? -2. Now the vertex is the point H, comma, K. So for this here, the vertex is the point -4, -2. Now our axis of symmetry is given to us for this here by the equation x equals h. Our value of h in this case is -. So once we have the general forms, or we have the values of a, h, and k, or really h and k is what we need, we plug them in. Questions on this here? We're ready for the next one. So A in this case is -3. H is -1, and K is 0. Since we do not have a value added on to the equation or being subtracted from those parentheses, that value would indeed be 0. Vertex is the point H, comma, K. So this here would be -1, 0. -1 for X, 0 for Y. Welcome back. Big note sheet.
No, it was actually good. We got some really good food.
We got to play games. I learned a new song. This is crazy.
All right. Axis of symmetry, X is equal to H, and our value of H in this case is -1. So the axis of symmetry is X is equal to -1. Questions on this here? You ready for the next one? So, g of x equals 2 times x minus 2 squared plus 5. So we're going to relate it back to the general form. A, H, and K. So looking at this here, what would the value of A be? 2. What would our value of H be? Positive 2, and K would be? Positive 5. Now in vertex form, this form here, again, the vertex is the point H, comma, K. And what's our value of H? 2. comma, then our value of k is 5. So the vertex is the point 2, 5. Now the axis of symmetry, A of S, axis of symmetry, is x equals h. And our value of h is 2. Okay. So here x is equal to questions on this here. We ready for the next piece. Now this here, standard form is ax squared plus bx plus c. Now we can relate the information in vertex form to standard form, especially when finding the axis of symmetry in the vertex. Now these here, don't write these down. This is kind of how we would go from one to the other. Am I hearing something knocking? Okay, I'm just hearing things. But the more important thing is this here. Now we know when the value of A is positive. When A is positive, the graph is going to open up. When the value of A is negative, we have a negative value for A, it's going to open down. The axis of symmetry in standard form is given to us by the equation x is equal to negative b over 2a. And the vertex is given to us by the equation, or by the point negative b over 2a comma f of negative b over 2a. And the y-intercept is the point C, because 0 comma C is going to be the y-intercept. So we look at this first one here. We're going to relate this back to the general form, our standard form of a parabola, a quadratic equation, ax squared plus bx plus c. A, B, and C. What is the value for A? 3. Because it's the number in front of x squared. A will always be the number in front of x squared. It will not contain the variable x squared. A is just the number 3. B would be negative 6. So we do take the 6, and because there is a minus, a negative sign in front of it, that would be a part of B. And the value of C is positive 1, or 1. Now the vertex is the point, or they told us it's the point negative b over 2a, comma f of negative b over 2a. And the axis of symmetry is x is equal to negative b over 2a. Now the first thing we need to do in finding the vertex and the axis of symmetry is actually find the value of negative b over 2a. So negative b. Well, what's our value of b for this here? Negative 6. Over 2a, well, a is 3. So really it's saying that this negative b over 2a is, for this problem, negative 6 over 2 times 3. Now we can do this by hand. Negative 6 is 6. 2 times 3 is 6. 6 divided by 6 is 1. Or we could have plugged it in the calculator and also gotten So, tell me what the value of negative b over 2a is, yes? So we know the x value of the vertex is 1. We also know the axis of symmetry, because the axis of symmetry said x equals negative b over 2a. So we're saying x is equal to 1. Now the question is this f of negative b over 2a? Well, now that we know what the value is, we're looking at what f of 1 is. Well, this is just function notation. And all this is telling us is take that 1 and replace every x in f of x with 1. Because at this point it is, we found the x value, now we just need to find the y value. Now if we do this by hand, 1 squared, 1 times 1 is, lo and behold, 1. Negative 6 times 1 is negative 6. We still have the plus 1. Now 3 times 1 is 3. Negative 6 plus 1 is negative 5. And 3 minus 5 is negative 2. So it tells us that the y value of the vertex is negative 2. That's it. That's all I want you to do is find the vertex in the axis of symmetry. Questions on this here? ABC. A in our case would be 1. B is 2, and C is negative 1. Negative b over 2a. Our b value in this case is 2. A value is 1. Now at this point here, we can plug it in the calculator and let it do it for us. Or if we did this by hand, the top would be negative 2. 2 times 1 is 2. Negative divided by a positive is a negative. 2 divided by 2 is 1. So our value for this should be negative 1. And we can fill it into the 2 spots for our negative b over 2a. So the x value of the vertex is negative 1. And the axis of symmetry is told to us to be x equals negative 1. Now at this point here, we can take that value of x and plug it in to our equation. So we get negative 1 squared plus 2 times negative 1 minus 1. Well, negative 1 squared, negative 1 times a negative 1 is positive 1. 2 times negative 1 is negative 2 minus 1. Now, for the most part, we do work left or right. But what is 1 minus 1? So that would just leave us with what? Negative 2. So sometimes we can move these around as long as we keep the signs the same. We don't mess with it too much. If we didn't, we just worked left or right. 1 minus 2 is negative 1. Negative 1 minus 1 is negative 2. We get to the same answer. So that tells us the y value of the vertex is negative 2. Questions on this here? We have one more of these, yes? I'm going to let you go on. So, were we all able to find this? Yes? Okay. Do what? Did you find the vertex? I can keep working. Okay. So, what were the values of A, B, C?
8 and 1.
8 and 1. This is what we got, yes? Okay. See if I can find the rest of this. And then we plug it into the formula, yes? Yeah, so I wrote 1 twice. So we can erase that. Negative b over 2a. I knew that was going to look a little weird at this point over here. Yep, don't need that extra. Because we would indeed have 8 over negative 8 over 2 times negative 2. The negative 8 would become positive 8. 2 times negative 2 would be negative 4, telling us that the x value of the vertex is negative 2. So the axis of symmetry would also be x equals negative 2. Now at this point here, there it is, we can plug it into the equation. So we plug negative 2 back into our equation and simplify. Negative 2 squared would be positive 4. Negative 8 times negative 2 is positive 16. So we have negative 2 times 4 plus 16 plus 1. 16 plus 1 is 17. Negative 2 times 4 is negative 8. And negative 8 plus 17 is equal to 9. And just because I know I paused the video. Order backwards. Let's see here. Order back. So the y value of the vertex is indeed. Because I know you saw me writing up here the whole time. I just wrote the whole thing in white. So, but it would show up later. But, are you ready for the next part?